Think about your daily commute for a second. You hop in your car, hit the gas, and just glide over miles and miles of smooth asphalt. We do it literally every single day, kind of taking the whole shebang completely for granted. But what's actually holding you up? Seriously, have you ever stopped to consider the absolutely monumental, almost invisible effort buried right beneath your tires? The sheer scale of human labor, the precision engineering, the raw materials needed just to let you drive to work, it is absolutely staggering.
Welcome to This Explainer. Today, we're going to bridge the gap between those quiet, super technical drawings on a computer screen and the massive, deafening physical labor out in the mud. We're using some really powerful visual evidence right from the field to show you exactly how a blueprint becomes reality. And by the way, to truly capture the scale of this stuff, teams often make videos with audios on site to document the progress, which really helps us understand the sheer magnitude of what's happening out there.
Okay, let's dive into this. Here's our roadmap following a real-world project in Uttar Pradesh, India. First, the engineering blueprint. 2, earth moving and site prep. 3, foundations of steel. 4, vital drainage systems. 5, pouring concrete. And finally, number 6, heavy machinery. Let's get started.
So kicking things off with Section 1, the engineering blueprint, before the mud.
Now, you might be wondering where this all begins. Well, before a single scoop of dirt is moved, incredible precision has to happen on paper. The structural integrity of a massive highway doesn't start out in the field, it starts in the microscopic details of engineering schematics. Take a look at this technical drawing for an elastomer pad. Notice those exact dimensions clearly marked? We've got an inner square measuring exactly 320 by 400, sitting perfectly within an outer footprint of 440 by 510. But check out the bottom. There's a very specific arrow designating the traffic direction. In engineering, orientation is quite literally everything. If a single component gets installed facing the wrong way, it can compromise the entire structure's ability to handle the dynamic loads of thousands of passing vehicles. No way around it.
So what exactly is this pad doing? Well, think of it like those shock-absorbing gel insoles you put in your running shoes. An elastomeric bearing pad is this specialized, super flexible block, usually made of synthetic rubber, that gets placed between a bridge's superstructure and its substructure. Because as cars and heavy trucks drive over a bridge, the structure actually moves, it vibrates, it slightly flexes. Without these pads acting as insoles to absorb that shock and accommodate the physical shifting, all that rigid concrete and steel would eventually just crack right under the stress. It's this micro-level engineering that guarantees our long-term safety.
Moving right along to Section 2, earth moving and site prep. Moving mountains.
But, blueprints only take us so far. Eventually, you have to take those clean, perfectly straight lines from the schematic and force them onto a messy, unpredictable, and very real landscape. To really understand that raw reality, we're grounding this explainer in a specific time and place. This is a major road project in Unnao, Uttar Pradesh, on July 6, 2026. Pinning this down gives us a really tangible, documentary look at the future of regional infrastructure development, right as it's being actively carved out of the earth.
Just look at the sheer scale of this earthwork. We've got a massive Tata dump truck here with its bed fully elevated, unloading actual tons of dark, heavy dirt right onto the graded site. You can clearly see those deep, thick tire tracks carved into the mud in the foreground, which really shows you just how soft and challenging this terrain is. Site preparation is literally about moving mountains of earth, right? You're modifying the natural landscape piece by piece so it can eventually support the immense weight of a modern highway.
All right, Section 3, foundations of steel, the hidden skeleton.
Once the earth is moved and the ground is prepped, we reach the next critical step, which is building the framework that holds everything together underground. Down in this deeply excavated, super muddy pit, workers are physically balancing on top of an immense, incredibly complex cage of woven steel rebar. Notice the sheer density of this metal grid, with those vertical columns extending high above the base. And it's so important to highlight the human element here, because despite all our heavy machinery, this intricate steel skeleton is being manually tied and assembled by workers, right there in the mud. They are making sure every single joint is totally secure before the next phase even begins.
So, the crucial point here is why this dense web of steel is absolutely non-negotiable. Well, here's a structural secret for you. Concrete is fantastic at handling compressive force, like weight pushing straight down on it, but it's surprisingly brittle when it comes to tensile force, meaning pulling or bending. By embedding this vital, dense steel skeleton into the foundation, it provides the structural integrity needed to counteract the shifting of that soft, muddy terrain we were just looking at. It basically acts as the permanent backbone that's going to sit out of sight beneath the road forever.
Which brings us to Section 4, Vital Drainage Systems, controlling the water.
Now, right alongside the steel, there's another critical component being buried underground. And this one is entirely dedicated to battling infrastructure's absolute greatest enemy, water. Without proper drainage, a brand new road can wash away or completely degrade in just a few heavy rain seasons. And this brilliantly illustrates exactly how they manage that water. Looking at these two angles, you can see a remarkably long, heavy concrete drainage pipe installed deep within a dirt trench over in Bonnie. Look at how the trench walls are shored up with those wooden planks to prevent cave-ins, and notice the standing muddy water already pooling at the bottom. These massive segmented pipes have to be perfectly aligned and sealed. And the crazy thing? Once the road is finished, drivers will literally never see this massive system, but it'll be down there working silently to pull hundreds of thousands of gallons of rainwater safely away from the structural foundations.
Next up is Section 5, pouring concrete, liquid rock.
Okay, now we arrive at one of the most transformative stages of construction. We've got our steel skeletons built, our drainage trenches dug and piped, and now it's time to encase it all. It's time for the liquid rock. The workflow here is a strict, absolutely unbreakable sequence. Step 1, weave the dense steel rebar. Step 2, set the sturdy formwork. Those are the wooden or metal molds that hold the shape. Step 3, execute the highly time-sensitive pour of the liquid concrete. And finally, Step 4, the ultimate test of patience, letting it chemically cure and harden to its maximum structural strength. If literally any of these steps are rushed, the final product is completely compromised.
Over in Dewaracola, it is a complete hive of activity. A massive mixer truck is pouring fresh, wet concrete right into a formwork bed, while workers are just in the thick of it in their rubber boots, manually spreading and leveling this heavy liquid rock before it starts to set. But contrast that messy, active pouring with the highly organized line of precast concrete slabs quietly curing by the roadside. They're already poured into heavy steel frames, just waiting to be installed. Using this clever combination of on-site pouring and precasting allows the whole project to move forward with maximum efficiency.
And our final stop, Section 6, Heavy Machinery, the muscle.
To tie this entire massive operation together, you need brute mechanical force. I mean, the scale of the dirt, the weight of the steel, the volume of the concrete, none of it moves without the muscle of heavy machinery. Let's see how this brute force builds the final picture. Notice this massive yellow excavator positioned on the graded surface, using its powerful hydraulic arm to carefully carve out the wet earth right alongside a beautifully finished, solid concrete barrier. You can actually even see the imprint markings left on the side of the concrete from the formwork we talked about earlier. Workers are standing nearby, guiding the machine operator to ensure exact precision. So the machine provides the raw muscle, but human oversight is what ensures the blueprint's precise dimensions are perfectly met.
And that really brings us full circle, doesn't it? From microscopic blueprint dimensions for shock-absorbing pads, to moving literal mountains of dirt, weaving steel in the mud, laying massive pipes, and pouring liquid rock. So I just have to ask, next time you're cruising down the highway on your daily commute, will you look at the road differently? Are you going to think about the thousands of tons of hidden steel, the miles of concrete, and the monumental human labor buried right beneath your tires? I really hope so. Thanks for joining me on this explainer, and keep your eyes open to the hidden world built all around you.